I'm continuing the experiments on the Tektronix 570 characteristic curve tracer for tubes. And what you see on the screen is the plate characteristics of a 50L6 beam power tube. Now, if you've watched my previous videos in this series on the 570 and on tubes in general, you know that the beam power tube is the culmination of a series of steps that started actually back with the original electron tube, the diode, then the triode, eventually the tetrode, pentode, and finally the beam power, which is basically called a beam tetrode because it works like a pentode, but it doesn't have an actual suppressor grid. With that as background, why am I doing this particular tube? Well, I would like to do a family of tubes, and I chose the L6 family partly because they are the most produced audio, high power audio output tube, and by high power I mean more than a couple of watts of output. They are the most produced tube in history. They've been produced in a variety of filament voltages and in a variety of packaging. They go back to the original 6L6, which is a completely different kind of tube. There are also beam power tubes, but the reason I wanted to show you this 50L6 is I'm now going to compare two Raytheon 50L6s as a baseline, and then we'll talk about the L6 family, come back and do some experiments on the 570. Okay, what I'm doing is I am comparing two 50L6 GTs made by Raytheon. These are new old stock tubes from back in the day. To the best of my knowledge, they are new old stock. In other words, they've never been used before. But since I bought them from a TV shop that was going out of business 25 years ago, I don't know whether they've been tried in other equipment or not, but they were still in their original boxes and they appear to be new old stock. So what you see is one of the plate characteristics. Once again, along the bottom, or I should say from left to right, is the plate voltage. From bottom to top is the plate current, and each of these steps is a grid voltage. Now I'm going to press the zero bias switch, and you see that is what the tube does when it has the grid grounded to the cathode. In other words, no bias. So that's tube A, and there's tube B. Notice there is a difference between the two. Even though they are made by the same company, they have the same date code, by the way. As you saw, they're in the same kind of boxes, and they appear to be identical. But even on the same production line at the same time, you do not get identical tubes. There's tube A again. There's tube B. So let's talk a little bit about the L6 line of tubes, and then we'll come back, as I say, and do a few more experiments. This is the RCA datasheet for the 50L6, which was one of the tubes most produced by RCA. It was used in the output stage of millions of All-American 5 radios throughout the 1940s, 50s, 60s, and I don't know, maybe they still even produce them today, but RCA is no longer in the tube business, so it's not an RCA tube. At any rate, it's a beam power tube, which means that although it's drawn as a pentode, in other words, you see a suppressor grid, it actually does not have a suppressor grid. It actually has beam forming plates. Now, the particular one we were using was the 50L6 GT. As you'll see, there are a variety of packaging methods, and because of the packaging differences, the tubes had to be built differently in some cases. This particular tube operates on 50 volts at 150 milliamps of heater current. It has a maximum plate voltage of 200 volts. You see that over here. A maximum screen voltage of 125 volts and a maximum plate dissipation of 10 watts. So let's now take a look at the family of L6 tubes and compare them. I'm going to be looking at 50L6, 35L6, 25L6, 12L6, and 6L6. Now I say ahead of time, the 6L6 is in a class by itself. It has the same terminology as these other tubes, but it's a much higher power tube. And we'll look at some of those at the end. So what I'm going to do is start with the one that was manufactured the most and work my way down. The 35L6 is essentially the same as a 50L6, 150 milliamps. They just reduced the heater voltage to 35. But the 25 does not have 150 milliamps. It has 300 milliamps, and that's important because if you're doing a series string of heaters, the current has to be the same in every tube. The 12L6, notice, went to 600 milliamps. So you may think you're getting away with something by using a 25 volt 300 milliamp or a 12L6, but actually the total heater dissipation, that is the total wattage delivered to the tube through the heater, is the same. Finally, the 6L6 is a 6.3 volt tube, but has 900 milliamps of heater current, and it's needed for the power that this tube delivers. So now let's take a look at the maximum plate voltages. Notice that the first 4 tubes, this whole family, have only a 200 volt maximum plate voltage. The 6L6, however, has 360 volts. The screen voltage is 125 volts on the 50L6. For manufacturing reasons, the 35L6 is a bit of an anomaly. And let me just not get into all that. Because of the way this one was manufactured compared to the 50 and the 25, the 25 is just a 50L6 with a 25 volt filament. But the 35L6 is a little different. It has a slightly lower screen voltage, and there are a few other things about it that cause it to be a little bit out of kilter. Generally, the characteristics of the 12, 25, and 50L6 are considered identical except for the heaters. Then finally, the 6L6 has a maximum screen voltage of 270 volts. Finally, and something that we'll see perhaps in a later video when we talk about designing output stages, is the question of plate dissipation. How much energy actually can the plate dissipate? And for most of these tubes it's 10 watts, but once again, as I say, the 35L6 for manufacturing reasons is a bit of an anomaly. The 6L6 on the other hand is 19 watts. Now let me show you this is a 6L6 tongue saw, and I have a couple of those that I'm going to be comparing a little later that to see, and then I think if I get that far and I haven't run out of time on the video, I'll also try a 5881, which is considered to be functionally equivalent to the 6L6s. At any rate, that's where we're going. So let's take a look at a couple of these other tubes for a second, and then go do some more work on the 5.7. This is a schematic from an RCA tube manual showing how beam power tubes, in this case these are 6L6s, are used in push-pull for an audio amplifier. In this case, they call it a high-power audio amplifier, but this design or something similar to it was used in a lot of hi-fi amplifiers and a lot of guitar amplifiers. So this is the typical application. The 6L6 is really the monster of the Midway. It's the high-power tube in this whole family, and as we saw, it dissipates almost twice as much on the plate as the smaller cousins. Okay, we're back on the 570 again, and what I have done is replaced the B tube, that is the tube on the right side as you look at the 570, with a 50L6, once again made by Raytheon, but this one was manufactured to military standards. It was, back in the day, it was called JAN, for Joint Army-Navy. And it was a system developed during World War II for where the Army and the Navy would collaborate on specifications for war material being manufactured. And they issued these under JAN specifications. Generally, JAN is regarded as a high standard. It's not the highest standard. Certain lab quality manufacturing standards were higher, but basically for use in the field, JAN was sort of the big gorilla in the room. So this, once again, is that first Raytheon, the one we looked at earlier, and there is the JAN Raytheon 50L6. Notice that there's a little bit more gain in, well, they look identical actually to me. There's a little shift as the circuits in the 570 settle down, but they look to me like they're essentially identical. That one is maybe a little bit lower, but the difference is trivial. You'd never hear it in any amplifier. So now what I'm going to do is I'm going to leave the same A tube in, and I'm going to swap out the B tubes one at a time. But what I'm going to be doing is going down in voltage. To do that, I'm going to have to take advantage of something that I showed earlier, which is, pardon the movement, this tube tester that is set up to supply filament voltage. And once again, that is because the filament voltages on the 570 are common. In other words, you can only have one filament voltage. So to drive the filament of the right-hand tube, the right-hand tube, I'm going to have to use a separate external power source. So let me set that up. Okay, what you see I've done is I've connected the filament to the tube tester and set the tube tester to put out a 50-volt filament. And what I want to do is I've left the 50L6 in here. I want to check it this way, and then I can put in a 25L6 here and lower the voltage on the tube tester to 25 volts and compare those. So this is the Raytheon non-JAN, and this is the JAN tube that you saw before. Now I'm going to turn this off, and swap out the tubes. So now we have a 50L6 on side A, displayed on the screen, and a 25L6 with its filament supplied from an external transformer on the right. This is the 50L6. This is the 25L6. You may notice that it is quite a bit higher. In fact, what I'm going to do is I'm going to go to 50 volts per division. I'm going to go to 20 milliamps per division on the vertical. There you see that tube, and there is that one. Now let's take a look at zero bias. There's zero bias for that tube. zero bias for that tube. So what we see is that the 25L6 is a slightly hotter tube than the 50L6. Now you're seeing this as I see it, so I'm as surprised by this result. I thought they would be the same. The tube manual says they're the same. But obviously this 25L6 is a hotter tube, and by that I mean it has higher mutual conductance, higher amplification factor than the 50L6, okay? Okay, now we're going to compare a 50L6 with a 12L6, and by the way, for those that might be curious, the tube I used, the 25L6 is a new old stock RCA. I'm also going to be using a new old stock 12L6 from RCA. So this is the 50L6. This is the 12L6. Now, I will also tell you I am actually running this 12L6 at slightly lower voltage. I'm actually running it at 10 volts on the heater rather than 12. And the reason is this particular tube tester, for some reason the 12 volt winding on the heater for this tube tester produces about 15 volts. So I dropped back a little bit. But it doesn't seem to have made any difference. It's still the 12L, this is the 50, this is the 12. See, it's a hotter tube. Now we've gotten to the big dogs. These are a pair of 6L6s. They're made by Tungsol. Show you the box there. And these are a fairly recent manufacturer. These are not new old stock. In other words, these are not from back in the 30s and 40s when the 6L6 was first introduced. These are 6L6 GCs. And we'll look at the spec sheet on these in just a little bit, or at least we'll look at a Tungsol data sheet from back in the day for the predecessor to these. These are actually a slightly improved tube. But this shows one, this shows the other. Now, these are not supposed to be a matched pair. I bought them separately as replacement tubes. Actually, I bought more than one, and I picked the tubes out of the ones that I ordered that best matched the amplifier that I was working on at that time. So these have sort of been picked over, and these are sort of the orphans of the pack, I guess you might say. But this is tube B and tube A. You see there is a slight difference in them. Now what I'm going to do is I'm going to replace tube B with a 5881. Okay, here is the 6L6, the 5881. Now, what I'm going to do is raise the voltage on the screen. I've raised the sweep voltage to 300 volts. So this goes out to 300 volts instead of 200. On all of the tubes, the other L6 tubes, I've only been using 200 volts. But that's because the 300 would exceed their rating. But I'm going out to 300 volts now on the 6L6 and the 5881. So let me raise the screen grid voltage to 150 volts, or maybe I'll make it 125 volts just to show you the difference. Notice the tremendous increase in gain. Now I'm also going to go back to the 6L6, and you see it also has greatly increased gain with higher screen voltage. So these are some of the parameters that you have to play with. And for many years, the choice was between going with a triode or a beam power tube. And in the 1950s, some clever engineers in Britain decided to try to split the difference. And they developed what was called the ultralinear amplifier, which used a split output transformer. I won't get into that. If you're interested in that, look for my videos on magazines 1, magazines 2, magazines 3, but at any rate, the the ultralinear was sort of splits the difference between a triode and these beam power tetrodes. So now let's take a quick look at the spec sheets for the 6L6 and the 5881 and then wrap this video up. Here is the original Tungsol 6L6 datasheet, and notice it covers the 6L6, the 6L6G, and the 6L6GA. And the one we've been working with is a GC. So let's take a look at the specs on this one first, and then we'll come back and look at the GC. You may notice, let me zoom in a little bit here, that the maximum plate voltage is 360 volts in the pentode configuration, and the maximum screen voltage is 270. Now we only went to 125, so we could have gone up quite a bit on the screen voltage. The screen voltage, however, should never be higher than the plate voltage. The plate dissipation is 19 milliamps. Let's compare that with the 6L6 GC. You may notice here, we have to move out just a little bit to see this, and you'll notice that the maximum plate voltage on the GC is 500, and the screen grid can be up to 450. Now there's a caveat on that, so always make sure that you read all the footnotes before you start trying to do a design. But notice that the plate dissipation is all the way up to 30 watts. So that's a substantially better tube than the old 6L6GA. Finally, here is the 5881. Once again, beam power tube, and pretty good specs. This is in the pentode connection, 400 volts on the plate, 400 volts on the screen, and a plate dissipation of 23 watts. Now, I mentioned the 5881 in connection with the 6L6 because recently El Paso Tube Amps did a comparison in which he replaced some KT tubes that are 6L6 equivalents, very close to it, with 5881s, and he thought he got better fidelity or lower distortion. I'm not sure that I remember, but anyway, he felt that it had improved the amplifier. So I commend you to take a look at his channel. He's got some great stuff on some of the similar things. But for now, I think I'm going to wrap up this video and tell you thanks for watching. Look forward to maybe a little bit of a change of emphasis in the next video, but I am going to continue using this Tektronix 570 and trying to resurrect the technical lore of the ancients in these vacuum tubes and electronic design. So, hope you enjoyed it. I hope you also learned something, but at any rate, have a nice day.